mentorship program contains the second unit, which is Introduction to the Fracture Mechanics. And under main topic, these are the subtopics like Introduction, Fracture Mechanics, Stress Intense Vector, Crack Tip Plasticity, Fracture Toughness, and Anchor. We have already covered Introduction and Fracture Mechanics in earlier videos. Now we will talk about Stress Intensity Factor. So before studying characterize the crack, let us consider three basic modes of crack surface displacement that structure undergoes under the loading. A crack in a structure can be stressed in three different modes. It is called opening mode, sliding mode, or tearing mode. The stress field at the crack tip associated with each of these basic modes of crack surface displacement can be considered as basic stress fields. And the stress field associated with any arbitrary mode of crack displacement can be obtained in terms of this basic stress field. Let us see the definitions of mode 1, mode 2, and mode 3. So in mode 1, which is known as opening mode, where the normal stress give rise to the opening mode denoted as mode 1, the displacement of the crack surface are perpendicular to the plane of the crack. In plane shear results in mode 2 or sliding mode, the displacement of the crack surface is in the plane of the crack and perpendicular to loading edge of the crack. The tearing mode or mode 3 is caused by out-of-plane shear. Crack surface displacement are in the plane of the crack and parallel to the leading edge of the crack. The superposition of the three modes describes the general case of cracking, and mode 1 is the most important along other two modes. If it is required to find out the disturbances of stress ahead of the crack tip of an infinite plate with the center crack of 2A, and any point ahead of the crack tip in polar coordinates can have sigma x, sigma y, and tau xi. Consider a through thickness mode 1 crop mode 2A in an infinite plate. The plate is subject to a tensile stress sigma at infinity. An element dx dy of the plate at distance r from the crack tip at the angle theta with respect to the crack plane experience normal stresses. So based on the analytical analysis using complex variables, one can determine the stresses of sigma x, sigma y, and tau xi. And obviously sigma z will be 0 for plane stress. And if in case of plane strain, there will be a Poisson's ratio effect where sigma z will be given as mu times sigma x plus sigma y. So basically the stress distribution in y direction, which is most important to be considered as applied load is along the y direction, is given by sigma square root of a by 2 pi r and function of cos theta. So this is what the distribution shows as a function of theta and r. So the narratives are the stresses are proportional to the external stress sigma, and they vary with the square root of the crack size and tend to infinite at the crack tip where r is small. For large r, the stress sigma y approaches 0, while it should go to sigma. Equations are valid only for limited areas around the crack tip. Each of these equations represents the first term of the series. And in the vicinity of the crack tip, these first terms give a sufficiently accurate prediction of the crack tip stress field since the following terms are small compared to the first term. So the general form sigma y is given this form is a function of theta, and where you can express sigma square root pi a as a k one, which is known as stress intensity factor. It describes the intensity of stress ahead of the corrective. For mode 1 is K1, for mode 2 it will be K2, and mode 3 it will be K3. The whole stress field of the corrective is known when the stress intensity factor is known. The stress intensity factors are generally available in the handbooks. This is published in UK. The another one is from USA, and another is from the Japanese. So these are not available in public domain. It is one has to buy it to refer to the stress and effect of different configuration, geometric configuration. The stress and effect can be determined based on either analytical or experimental or combination of both. From the analytical point of view, you have a stress function method, you have a strain function method, energy release method, and weight function method, and finite element method, and methods using integral transformation method. Thank you.